We're going to work with just basic standard normal random variable, several problems. Given that z is a standard normal random variable, compute the following probabilities. Part A. Probability that z is greater than or equal to 0 or less than or equal to 0.83. Now, coming to the table, we can see that this table shows us the cumulative distribution under the curve, all the way from negative infinity to any given z value that we read. So we want to know the probability of this distribution. If this is the z distribution, we want to know the area between 0 and 0.83. So this is all that we're looking for. But this table right here, over here, gives us all the area to the left of z, 0.83. So we need to find first 0.83. Here's 0.8. Here's 0.03. At the top, at the intersection, you will see 0.7967. 0.7967. So we know all the way from here to here is 0.7967. This is from the table. But we're not interested in all of this. We're only interested in this one. Since we know this left half of the curve is 0.5, with a simple subtraction, we can find the answer, which would be 0.7967 minus 0.5. And that should give us 0.2967. The next part says, what is the probability that, I'll do it over here, probability that z is less than 0 but greater than negative 1.57. So now I go to the negative side of the table that I have. I find negative 1.57. Well, let me draw the curve first for this. Here's the curve. We want the area where z is less than 0 but greater than negative 1.57. So this is the area that we want. So we have negative 1.57, which I'll come to the table and I'll find. Negative 1.5, and then across the top I find 0.07, and I find 0.0582. 0.0582. 0.0582 would be this area right here. 0.0582. 0.0582 would be this orange area right there. And the reason why I know that is because this table in your book gives me the cumulative area all the way from the left margin of the left end of the curve all the way to the z value that I read from the table. So I know this end area is 0.0582. But I'm interested in this shaded area. Now, because I know the left half of the curve is 50% of the area under the curve, or has a 0.5 probability, 0.5 minus 0.0582, which equals 0.4418, would be the answer to the question. 0.4418. And so that would be the answer to this question. Another problem that we can answer is probability that z is greater than 0.44. Probability that z is greater than 0.44. Again, draw the curve on the z-axis. Here is 0. Greater than 0.44 would be this area that we're after. We want to know that. But here is 0.44. But this table gives us, oops, I'm using the negative side. I should be using the positive z-value side. So I look 0.44 on the z-axis, and I find 0.67 as the area. So I know all of this area to the left of z that I looked up is 0.67. Since I want this small tail, the answer would be, since total area under the curve is 1, I would have 1 minus 0.67, so approximately 0.33 would be the area over here, and that would be the answer to this question. For this area right here. The next question is, what is the probability that z is greater than or equal to negative 0.23? What is the probability that z is greater than or equal to negative 0.23? Yeah. Draw a curve. Here's 0 on the z-axis. Negative 0.23 would be to the left of 0, negative 0.23. And we want the area above that or higher, for z values higher than that. So all of this is what I'm looking for. So because this table with the negative z values gives me all the area from the left tail, from here, to that z value, if I look it up, I get negative 0.23, negative 0.2, sorry, negative 0.203 across the top. I come down and I see 0.4090, 0.4090, 0.4090. So this tail is 0.4090. Since I want this shaded area, all of this would be 1 minus 0.4090, which would be approximately 0.591. 0.5910. So that would be the answer to this question. Another part of this problem says, what is the probability that z is less than 1.2? Here z equal to 0, less than 1.2 would be all of this area. This is a simple reading it off of the chart. I come to the positive z values. I look up 1.20. The table entry is 0.8849. 0.8849. And that would be the answer to that problem. And finally, the last question is, what is the probability that z is less than negative 0.71? Draw the table, draw the key. Here's 0, negative 0.71. That would be all of that area. Oops, sorry, my mistake. This is a negative number, so it would have to be to the left of the mean. So scratch that. 0, negative 0.71 on the z-axis would be to the left of the mean, and we want to know the area below it or less than that, so that would be this area right here, and that's a straight reading off of the negative z table. Negative 0.71, you go to negative 0.7, across the top go to 0.01, at the intersection you see 0.2389, 0.2389. So we know all the area to the left of the z value that I just read would be 0.2389. So all of this is 0.2389, and that's the area that I'm looking for. So this would be the answer, 0.2389. Thank you.